Okay, so here chapter 7 we have to start now, that is from electrical circuits. So chapter 7 we have sinusoidal steady state analysis. So before sinusoidal steady state analysis in chapter 7, just to recall in 1 minute what we studied in previous 6 chapters. So in 6 chapters we studied about the DC analysis with resistance, capacitance, inductance, and node analysis, mesh analysis we studied, and we studied about the superposition theorem, source transformation theorem, Norton's theorem, Thevenin's theorem, then maximum power transfer theorem also we studied. So after this we started AC circuit, that is before the AC circuit we studied about the phasors, and before the phasors we studied sinusoids, how the sinusoid will behave with the AC circuits, means sine cosine circuits or sine circuits, and then we studied phasors. In phasors we converted this sinusoid to time domain to frequency domain. In that we use complex variables like 1 plus jx, that is rectangular coordinates. Then we use polar coordinates. Then we use what we call another exponential coordinates, exponential functions we use. Then we related with inductance, capacitance, voltage and current. Now we have to study about the analysis like what we studied in DC, like node analysis, mesh analysis, and superposition theorems, and Norton's theorem, all theorems. So one by one we study. So the same it repeats now with sinusoidal, means AC circuits. With AC circuit we will study the node analysis, will study, then mesh analysis we will study, then we study superposition theorem, so source transformation, and Thevenin's and Norton's equivalent circuits. One more topic extra will be there here. It is called instantaneous and average AC power. This we didn't study in DC. We already studied this one in the, I think, chapter 2 or chapter 2 we studied, I think, power, how much power, how much energy we studied there. Here also we study in with AC, instantaneous and average AC power. Okay, so today we will finish the nodal analysis and mesh analysis. One example we will study. Then remaining in another 2 lectures we will finish, inshallah. So 3 lectures in chapter 7. So for before going to node analysis and mesh analysis, what are the steps we will study? So in this chapter we want to see how node analysis, mesh analysis, Thevenin's theorem, Norton's theorem, superposition and source transformations are applied in analyzing AC circuits. So till now what we studied, DC circuit was there. Now we study with AC circuits all these items. Analyzing AC circuits usually require only 3 steps. In that one step also we can remove also, but we require 3 steps. First one, transform the circuit to phasor or frequency domain. See that whatever the circuit is given, it must have what it will have: inductance it may have, resistance will have, and capacitance it may have. And what is the power? Means voltage and current, it will be in AC format, that is in Vm sin omega t or Vm cos omega t plus phi, like this. In this AC format is there, but it is in which domain? It is in sinusoid. It is in sinusoid will be there. So first step we have to do is, whatever you have in the sinusoid, that is called time domain. The time domain we have to convert it into phasor or frequency domain. We have to convert first, what we studied in the chapter 6. Now solve the problem using the circuit techniques, that is node analysis, mesh analysis and superposition. So the chapter 3 and chapter 4 what we studied, mesh analysis, node analysis, that we have to implement the same steps, no other explanation for that. Then in examples you can recall your old knowledge. Now superposition and Norton's and Thevenin's theorem, we have some extra techniques here that we will study, don't worry. Now then again, once you got the solution after the all analysis and all the steps you followed, then again transform back to phasor to frequency domain, that is time domain. The phasor or frequency domain to time domain, transform back. See, the result should be in terms of cos and sine only, means the instantaneous voltage and current values are in cosine terms, Vm cos omega t plus something. So like this we have to transform back, means we have to convert back into time domain. So step 1 is not necessary. Step 1 is not necessary if problem is specified in frequency domain. If let us take your problem is given in frequency domain itself, like rectangular, what it's called, 1 plus jx, x plus jy, or frequency domain is a at an angle 30 degrees, like this. It is given already in the frequency domain, no need to transform there. Means step 1 needs no need. So in step 2 means that is analysis, node analysis, or super mesh or mesh analysis, or superposition theorem. In step 2, the analysis is performed in the same manner as DC circuit analysis, except that complex numbers are involved. In DC circuits, directly multiplication division was there. Direct equations are there. We have to solve the equations in 2 techniques. What are the 2 techniques we used? One is Cramer's technique we used, and elimination techniques we use. Cramer's is matrix method. Elimination technique is 2 unknowns, 2 equations. We use the elimination techniques. So like this, we use there the same technique here. You have to use, but only thing is complex numbers are there here. 1 plus j, x plus jy, like that. We have to step them. Now let's have an example for node analysis, so you'll understand. So node analysis. Let's have an example. Find Ix in the figure, circuit of the figure with node analysis. See, observe the question properly. Which analysis I am asking? If nothing is given, find Ix. Then you can have any technique. You have many techniques in electrical circuit to solve it. But if I mention in the question itself, use node analysis, use mesh analysis, use superposition technique, use Thevenin's technique, then you have to use that technique only, no other way. Now, see the circuit here. In the circuit, what are the elements we are giving? Same technique we have to use node analysis previously what we studied. First we have to see how many branches, how many elements, then how many nodes we have to see. Okay, see here, how many nodes we have here? 1, 2, and this is the reference node, right? 2 nodes we have, and with reference node, 2 plus 1. Total 3 are there, but in node analysis, 1 is reference node, that is 0 node, it is already given. So we need a 2 node equations. Okay, as per a sinusoidal AC analysis, what is the first step? If any sinusoids are there in the form of sinusoids, then that is sinusoid means time domain. If any time domain is there, we have to convert into phasor. Check, is that all are in time domain? Yes. How? What is the voltage here? 20 cos. When sine cos terms are there, that is called 4t. Time domain means time is coming 4t. Cosine term with 4t. What is the format? It is 20 cos omega t. What is omega? That is radians per second. Omega is equal to 4. Then t is your time domain. Now this you have to convert, all this you have to convert into the frequency domain or phasors, in terms of you have to convert step 1. Then use node analysis step 2. Okay. So we convert the circuit to the frequency domain. First one. What is 20 cos omega t? 20 cos omega t or 20 cos 4t can be written as at an angle 20 with an angle 0, because in this it should be in the format 20 cos 4t plus 5, means some degrees it should be there. That degree will come here in this radian in the frequency domain, 20 at an angle 0 degrees. Now in this 20 cos 4t, what is omega? Cos omega t. Omega is nothing but 4. So omega is 4 radians per second. This first conversion. Next conversion, each element. Resistance. If you want to convert the resistance R in phasor or in time domain, both are same. It is a real part. Now convert this inductance. 1 Henry can be converted. This inductance is nothing but J omega L. C capacitance is converted in the frequency domain is nothing but 1 by J omega L. 1 taksim J omega L. These two you have to remember. Okay. C is 1 by J omega L. L is J omega L. So omega already we have, L we have, then multiply it. That's Alatul. That is omega L. Omega is 4. So it's coming from this equation 20 cos 4t. This is omega is 4. So 4 multiplied by L. L how much? Wahid Henry, 1 Henry. So J4 is your reactance. We call it as reactance, right? We got two parts in the impedance. One is resistance and one is reactance. R plus JX. X is reactance. That reactance JX is reactance, may be capacitive, may be inductive, depends. Plus JX is there, that is inductive. Minus JX is nothing but capacitive. So that will come, see here. Now coming to the another inductance, 0.5 Henries. What is a 0.5 Henries? 0.5 Taqsim Arba. So 2J. J2 is your second inductance. J2 is your this second inductance. This here 0.5 Henries is becoming J2. Now another capacitance. Baki had a capacitance. The capacitance is 0.1 farads. Maybe sometimes it may give micro milli, but simply he is giving it is only farads, because calculation you may get error. So that's why 0.1 farads. So what is the equation for time domain to frequency domain to convert the capacitance? 1 by J omega C. So 1 Taqsim Zarb J omega is Arba and 0.1. So 0.4 it will come. So 1 divided by 0.4 come. Why Taqsim 0.4? How much? 1 divided by 0.4. It is 2.5. Okay. So 2.5. So it will become 2.5. 2.5 Taqsim J. Now Taqsim J is not good quantity, right? So 1 divided by J, I want to become J. What it is there? Multiply and divide with J. Okay. So I will write here. So here next is this one. This is nothing but 1 J omega C. So what it will become? 1 divided by J, that will become 0.1 into 4. So what it will become? 1 divided by J 2.5. Now 1 divided by J, how can I write? 1 divided by J multiplied by J divided by J. Okay. Now J into J, what is the equation? J is nothing but minus 1, J square. J square is equal to minus 1. So minus 1, it is coming here, it will go up. So it become minus J. It's nothing but J divided by J square. J square is minus. So it become now minus J 2.5. It become minus J 2.5. Okay. So I can remove this. It is. So what is the result for this? Or we can remove directly, I think, right? It is all. Okay. Okay, now check. 0.1 farad is nothing but minus J 2.5. Okay, now the frequency, now we got all the elements. 0.5 Henries is become J2. 1 Henry it become J4. 0.1 farads it become minus J 2.5. We got it. Okay. So next, how the figure will be? This will be like this. Check here. First one, the voltage. Okay, first one, the voltage 20 at an angle degree, because 20 cos 40 we converted into 20 at an angle 0 degrees. Now 10 ohm resistance as it is in what we call time domain and frequency domain, resistance will act like a same. No changes. So now capacitance 0.1 farad was there. Now it is minus J 2.5. Here 0.1 farad is minus J 2.5. We are writing here. Now 1 Henry we converted to J4. 1 Henry is now J4. Now 0.5 Henry is nothing but J2. J2 we are converted. Now everything redraw the circuit with your phasors, with your frequency domain elements. Okay. Now we need the next step 2. Step 2 is nothing but node analysis. Same like a DC circuits. Node analysis we have to do. Same steps we have to follow. How the node analysis we do. So in the node analysis, what we'll do? We point out the nodes with one reference node, 0 node. So here node 1, node 2, where we want to find V1 and V2. So at this node, arbitrarily you can mark the current based upon your experience. So if the current already Ix is given downwards to the ground, no problem. Remaining current I can mark. So because of this voltage plus is there, the current will leave from the plus, generally from the source voltage. So it will enter the node 1. So if node 1 current is entering, another two currents will leave. Already Ix is leaving from as per the question, and another current I can mark as a leaving. You can assume, no problem. Later if you come minus, you can change it. So current is leaving from this node. So at this node, currents entering is this from this resistance, current leaving is to this inductance and to this capacitance. Now second, node 2. Node 2, this is a current source, dependent current source, where it is depending on this capacitor. So this dependent current source is entering to the node. So we cannot change that one. You no need to again assume there. Already current entering is there. Now remaining, once it is leaving from here, you cannot assume that is a leaving from here also. Because another node it is leaving, it should come join here. So current is joining at this node, means entering. Now in this two entering is there, are there as per our experience I am telling. Two entering is there, one should be leaving, right? Everything cannot be entered in the node. So two already enter is there. So one I can assume as a leaving. So I mark as a leaving there. This you can mark by your own, no problem. Because in this circuit nothing is given, only Ix is given, right? Direction. So remaining direction we have to mark as per the observation. So now start the first node. What are the equation? So V1 at the first node. How can I write node analysis equation? Higher potential to lower potential. In this complete V1 to ground in this branch, where is the higher potential? 20, because this is a plus. Higher potential is 20 minus V1. Right? Higher potential is 20 and minus V1. Taqsim Ashra, because this is a resistance. So I can write that one. Then another branch, this one. Current entering. There is only one entering is there. Okay. So leaving is nothing but V1 divided by 0. V1 minus 0 divided by Z, that is minus J 2.5. What is that? Voltage divided by resistance is nothing but current. We need the current only for the node analysis. So V1 divided by J minus J 2.5. That is the impedance. V1 divided by impedance. Now another one. V1 minus V2, because this is the higher potential and this is the lower potential. Current is leaving. So V1 minus V2 divided by Taqsim J4. So that is your first node equation. Check here. This is first one. 20 minus 10. 20, that is 20 minus V1. That is voltage. 20 is the higher potential. V1 is the lower potential. 20 minus V1 divided by 10. Current entering. Now leaving are these two. So that is equal to other side, because equal to other side, current entering and these are current leaving. So two are the current leaving. So V1 divided by this one, first second branch, V1 in the capacitance, V1 divided by minus J 2.5, V1 divided by minus J 2.5. Now next V1 minus V2 divided by J4. Now here the point will come. What is the equation? I will write here. Okay. So just rearrange this one. Okay, I can write. I am just pointing here, no problem. So 20, I can put 10. Take this side. This is 20. Then minus 20 equal to, you can take 20 this side and V1 also this side. So V1 and minus J I can take on the top. Minus 10 V1 divided by 2.5, that is J 2.5. J 2.5 next plus V1 10 V1 divided by J4, 10 V1 divided by J4. Next minus 10 V2, because 10 I took this side, divided by J4. Now rearrange this one. This side 20 only will be there. 20 will be there. 20 equal to, what is V1 separate? V1, you can separate the V1s here without J. So V1 is there. It is here. So V1 is nothing but here. That is V1 minus Here 10 divided by 2.5, how much? 10 divided by 2.5, it is 4. So it become j, if you take upside, it become how much? It is 1 by minus was there. If you take j out upside, it is plus 4j v1. Okay, and next here 10 divided by 4. What is 2.5, right? 10 divided by 4, it is 2. Sorry, 2.5. 10 divided by 4, 2.5 again here. It is plus j 2.5. This is also v1. Now next 10 divided by 4 again 2.5 again. Then j, if I am to take upside, it become plus j 2.5 v2. This is the equation. Now how many v1s are here and v2s are here? Here 4 minus 2.5, how much? 4 minus 2.5. Here no, here it should be minus. Okay, it is. Yep. Pen. Here minus j, because 1 by minus j 2.5 is there. If it go upside, it become plus. And again minus, then j square, so it become minus. So it become v1 is there, and 4 minus 2.5, it is 1.5. So it is 1 plus 1.5, that is j 1.5. You can take v1 out, this one, plus j 2.5 v2. So like this one equation will come. You can check here. 1 plus j 1.5 v1 plus j 2.5 v2 equal to 0, equal to 20, sorry, equal to 20. So you can erase all. Okay, now like this, if you rearrange this equation, you will get 1 plus j 1.5 v1 plus j 2.5 v2 equal to 20. You got the rearrange and all this. You can do it your own, no problem. I already did it. Now the first equation. Now go to the second at v2. At v2, what equations we can write? Note 2. We can write v2 divided by j2. That is one equation. v2 minus 0 divided by j2. One equation here. Here v2 minus 0 divided by j2. One equation, because current leaving, and equal to other side, because all are entering. Now entering is nothing but v1 minus v2, higher potential to lower potential, v1 minus v2 divided by j4, and plus current is entering, so 2ix. What is ix? Again we can substitute from v1 by minus j2.5. So let's see another equation. Yeah, at note 2. So at note 2, see, I'm starting with this one, that is my 2ix. 2ix is entering, first plus v1 minus v2 divided by j4. This is one side, because current entering, equal to current leaving. Current leaving is this one, v2 divided by j2, that is v2 minus 0 divided by j2, that is v2 j2. Now what is ix? What is ix here? Ix is nothing but this one. This ix is nothing but v1 divided by minus j 2.5. So substitute here ix. So what happens? It is 2v1 divided by minus j 2.5. So we have to rearrange that one. So it will become 2v1 minus j 2.5, v1 minus v2 j4, and v2 by j2. Now rearrange this one. Okay, now we have to solve this equation, and this is 2v1, right? Okay, now what I can do here, okay, multiply both sides with 20. So it is becoming multiply both sides with 20 to become easy. Then what happens here is 40 divided by 2.5. 40 divided by minus j 2.5 v1. Just rearrange this v1 separate. 20 v1 divided by j4 minus 20 v2 divided by j4 equal to 20 v2 by J2. Now 40 divided by 2.5, how much anyone? 40 divided by 2.5 is 8, I think. No, 16. Okay, this is 16, and minus j if you take our upside, what happens? Minus j if you take upside, multiply with j and j. So j square. J square is nothing but minus 1. So it become plus. So it is plus j. So it become here plus j. How much I am getting here? 40 divided by 2.5, 16. 16 V1. Now here also 1 by j, if we go upside, it become minus j. So minus j, 20 divided by 4, 5 V1. Now here also 1 by j, it become up, it become minus j. So minus minus plus. Plus j, it become 20 divided by 4, 5 V2. Now I take this V2 this side. So it become, first it become minus, it become here plus. So 10 j 10 V2 because 20 divided by 2. Now just sum and minus this one. 16 minus 5, how much? 11. 11 J1 JV1 and V2 plus 10 plus 5 because all are plus 15. 15, that is J 15 V2. So this is the equal to 0. Here also equal to 0. So this is the equation. Just you can check. 11 V1 plus 15 V2 equal to 0 you are getting. So it is all okay. So if you rearrange this equation here, if you rearrange this equation, multiply both sides with 20, anything you can do. This may not be 11 V1 or 15 V2. It may have small fraction value also, up to you, but the result will be the same. So it is coming, if you rearrange and multiply both sides with 20, then you get 11 V1 plus 15 V2 equal to 0. Okay, this is the second equation. The first equation already we got. What is the first equation? It is 1 plus j 1.5 V1 plus j 2.5 V2 equal to 0. You can see the first equation. See, the first equation is 1 plus j 1.5 V1 plus j 2.5 V2 equal to 0. So now substitute here in the matrix form. Put it in the matrix form. So V1, V2 is here, 20 and 0 is here. Now what is delta? Delta is nothing but multiply diagonally minus this other diagonal. So 1 plus j 1.5 multiplied by 15. You will get it. So, okay, I will do it for you. Pen, okay. So, how we are getting the 15, this one? This one is nothing but 1 plus j 1.5 multiplied by 15 minus j 2.5 diagonal multiplied by 11. Now 15, I mean 15 plus 15 into 1.5, how much? 7.5, right? No, 1.5, 22.5. So it is j 22.5 minus 11 into 2.5. 11 into 2.5. 27.5 minus j 27.5. Okay. Now 15 is separate because j terms not there. So this is the 15. Now 22.5 minus 27.5. How much? 5. So which is the bigger? 27 is the bigger. So minus. So minus j 5. This is the, you see, we are getting 15 minus j 5. So it is all. Now laser point. Okay. Now coming to the second one. How we will get the second matrix? We have to just remove the first column with the equal to other side. That is nothing but. So we have to write 20. That is the first column. You remove this first column and write 20 and 0. Second column as it is j 2.5 and 15. Like this. Now what is the resultant? Delta 1. Delta 1 is resultant is nothing but I can write diagonal multiply 20 multiplied by 15, which is equal to 300. Okay, other diagonal minus 0. Now coming to here, in this the first column I am putting as it is. First column I am putting as it is. Second column I am rearranging with this. So 1 point become this one 1 plus j 1.5, next 11. Now it become 20 and 0. So diagonal multiply by diagonal. So 1.5 1 plus j 1.5 multiplied by 0, it is 0 minus this is 20 and 11. 20 multiplied by 11, it is minus 220. So we are getting this one. So once you get this, what we have to do? We got delta 1, delta 2, we got delta. So what we need? V1. What is a V1? V1 is nothing but we can write V1 equal to, we can write as per the delta 1, delta 2, V1 is equal to delta 1 divided by delta, which is equal to, what is delta 1? 300 divided by 15 delta minus j5. So for this, what we are easy solution is 15 minus j5 you have to convert into rectangular. So for this under root, that is 300 converted into polar. This rectangular convert to polar so that division will be easy. So 15 minus j5, how to convert into polar? It is nothing but under root of 15 square minus plus or minus. What is this? Plus or minus? Plus? Yes, plus. Okay. 5 square. Now angle. It is nothing but, angle is nothing but tan inverse B by A. That is 5 minus 5. Minus 5 divided by minus 5 divided by y by x, 15. Now find the angle. Okay, this is 15 square and square root of 15 square plus 5 square. Close the bracket. 15.81. This is 15.81 is coming, and at an angle. Angle should be like this. At an angle, tan inverse. So tan inverse, minus 5 minus sign divided by 15. You are getting how much? Minus 18.43. But it is plus or minus? Just let me check. Yeah, minus. So it is minus 18.43. This is this one. So if this minus 300 divided by 15.81 at an angle minus 18.43. So this minus 18.43, if we go up, it become plus 18.43, and 300 divided by, directly you can do 300 Taksim 15.81. So it become 18.9. So this equal to, this equal to 18.97 at an angle of plus 18.43 degrees. So like this you will get, you can check the answer. So V1, delta 1 divided by delta 300 divided by 15 minus j5 is equal to 18.97 at an angle 18.43. Okay. Now what is V2? V2 is nothing but delta 2 divided by delta, which is equal to, I can write as delta 2 minus 220 divided by already I calculated that one, 15.81 at an angle minus 18.43 degrees, right? 18.43. We already converted that one. Okay. Now 220 divided by 15.811. Okay. 13.91. This is equal to 13.9. That is minus, sorry, minus 13.91 at an angle. This will become plus 18.43. But the answer is not good. Why? Because minus sign is there. You have to put the minus sign inside. So What we have to do? 13.91 at an angle 18.43 plus 180 degrees. Because minus sign, if you want to remove, that minus should go inside, means you have to add 180 degrees. So it become 13.91. How much is total? 180 plus 18. 180 plus 18. 198.43 degrees. So check the answer. 198.3 degrees. 13.91, 198.3 degrees. So now erase all, so you can see it. Okay. So this is your answer. So V1 we got, V2 we got 13.91 at an angle 19.83. Now what we need? We need Ix. What is Ix? Is nothing but V1 divided by J 2.5. V1 divided by J 2.5. So Ix is nothing but V1 divided by minus J 2.5. So substitute what is V1? 18.91 97 at an angle 18.43 divided by minus J 2.5. Now convert this minus J 2.5 into polar form. What is the polar form of the minus J 2.5? Can anyone? It is 18.97 or 91, 18.97 divided by polar form of minus J 2.5. Anyone? Can anyone get it? It is 2.5. That is what we have to do. X square plus y square under root. X is 0. Y square. So y square under root is y only. That is 2.5. 2.5 at an angle. What is the angle? Tan inverse of y by x. So tan inverse of y by 0. Tan inverse of y by 0. What is y? Minus 2.5 divided by 0. Tan inverse of 0. What is it? 90 degrees. Right? Tan inverse of 0. I will put it here. I will check. So tan inverse of 0. Minus J 2.5, right? Tan inverse of this is 2.5. So it is 90 degrees it will come. Okay, let's see here. That is minus 90, sorry. Minus 90 it become, because minus J it is there, minus 90 is minus 90 degrees. Now 18.97, if you divide, it is 7.59. Now angle, if we go on the up, minus 90 it become plus. So 18.43 plus 90, it is 108. So like this we have to find this one. Okay. So Ix we got 7.59 at an angle 108.4 degrees is your answer. So what is the time? Oh, good. Okay. So then if you convert this 7.59 into time domain, that is Vm 7.59 as it is cos omega t, 4t already is there. What is the angle phi? 108.4 degrees coming here. So this is your final answer. We have to return back, means convert back to time domain from the frequency domain. So this is the steps what we involved. I know this is the longest steps we have. So in the final exam like this, if I ask from this chapter 7, for chapter 7 only I will ask the long answer questions from chapter 7 or Norton's theorems, and which chapter it is? Chapter 5 I think, right? Chapter 5 and chapter 7 you will get the long answer question for maybe 5 or 6 marks. Okay, so because the length is more here. 5 and 7. 5 also same thing, that is what we have. Superposition theorem, Norton's theorem and Thevenin's theorem. That is also a lengthy process. And 7 also we have big problems. We have to do time domain to the phasor domain, then we have to go all the analysis, then we have to convert back to the time domain. So that's why. Okay, I will stop here. Okay, let's start. So we were in the chapter 7, sinusoidal and steady state analysis. Already we started in the last lecture. So we studied here node analysis. So in this chapter we will study all the topics what we covered in the DC analysis, like node analysis, mesh analysis, superposition theorem, Norton's theorem, source transformation theorem, power, instantaneous power, everything we'll study. Okay, so already with this we studied. Now you go to the node analysis directly. So we finished node analysis also. Before going there, what are the steps we discussed? So first we have to transform the circuit to phasor or frequency domain. If any circuit is given, generally it is given in sinusoid form, then it has to be transformed to the in phasor or frequency domain. Now then you have to solve the problem using circuit techniques like node analysis, mesh analysis, superposition, Norton's, maximum power, whatever the question is there. Now again transform the resulting phasor to time domain, sinusoid. So then that will be your final step. So if step 1 is not necessary, if problem is already in the frequency domain, already it is given in the frequency domain like polar and rectangular form, then directly we can go with the techniques. So node analysis we already finished. What we did already, you know, in the previous lecture. That's we already transformed this sinusoid cos of 4t and all this into phasor. Then we had a nodes here, node 1, node 2. Then we had equations and we found the result in polar form, that is frequency domain form. Then we converted back into sinusoid. So now this is node analysis only. The final result I am to show. Yeah, then this is your final result V1 and V2, and Ix we want, we got it in the phasor, that is frequency domain in polar form. Now we have to convert it back to sinusoid. So it will be 7.59 cos 4t at 108.4 degrees. This is how we will do in the steps in the node analysis. Now come to the mesh analysis. Same way we have to do, but the analysis is the same what we did in the DC analysis. Only here the extra thing is here we have to take care about the sinusoids. First we have to convert into the which form? Phasor form. Then we have to solve with the equations by mesh analysis, that is applying loop equations. Then we will go for the result, then convert back into the what we call sinusoid. Okay, well, determine the current I0 in the circuit using mesh analysis. So this is a circuit and it has 3 loops, already it is given, or we can see and you can check. This is the I1, this is the I2, okay, I2 is here and I3. Now what are the elements we have here? One resistor and the second resistor is here, and one inductor and 2 capacitors and 2 voltage sources, one voltage source and one current source. Okay, so we need I0. What is the current I0 due to this voltage source in the complete circuit? So by finding the mesh analysis, we can directly get the result. So first convert this into which form? Phasor form, that is frequency domain. Then start the mesh analysis. Okay, applying KVL to mesh 1. Now see here, in which form it is given? Already these are given in the phasor form. So no need to convert, because 28 and angle 0 degrees is a phasor form. It's a polar format of a sinusoid. And this phi at an angle 0 degrees, this is also a polar form of a sinusoid, means phasor form. Now resistance, sinusoid and the frequency domain both are same. Now inductance generally it should be in henries, right? Now it is converted to phasor form with J10 ohms. That is, this is reactance we call. So what we have, inductance in terms of admittance, 2 parts will be there, resistance and reactance. So this is the inductive reactance. Now capacitance also, it should be in farads, but it is already converted and given, that is minus J2 ohms reactance, capacitive reactance. This is also minus J2 ohms, that is a capacitive reactance. So how we can, without the symbol, see these are here, I can know that this is a inductance and we can know that these 2 parallel lines are capacitance. But without these symbols, how can I know this is a capacitance and this is a inductance? By plus J some quantity. Plus J some quantity is a inductance, inductive reactance. Minus J some quantity is the capacitive reactance. Directly we can understand. Minus J means capacitance and plus J means inductance. Without giving the symbol here. See, symbol I can understand, it is inductance. but I am not giving directly. I will tell this much reactance, this much reactance. Minus J10. What is it? It is a capacitor. Plus J15. What is it? It is a inductor. So like this, by seeing itself, we can tell. Okay, so because there is already the SRR in phasor form, no need to convert to the sinusoid to phasor form. Already they are there. So directly we can go for the loops. So the first loop here. So for the first loop here, how can we write the first loop here? 8 for I1. What are the I1? It is there. 8 is there. J10 is there and J2 is there. Minus J2. So 8 plus J10 minus J2 will be I1. See, 8 plus J10 minus J2 will be I1. And I1, not only in this 8 ohms, only I1 is flowing. But in J10, I3 is flowing. So J10, I3 also will come. J10, I3. Why minus? Because the current is opposite to this I1. I1, the I3 is opposite. So minus J10, I3. Now in this capacitance, not only I1, I2 are also flowing. So what is I2 is flowing here? Opposite to the I1. So minus of minus. That is plus J2. So that's why minus in brackets minus J2 I2. That is it become plus it is. So this is your first equation of this loop. Now second equation of the loop, you have to tell me. So what will be the second equation of the loop? Can anyone? How many elements are there? First for the I2, 1, 2, 3 elements are there and one source is there. So current is entering. So no problem. It is minus J20 at an angle 90 degrees. Current is entering or leaving. If it is entering is positive or leaving is positive. Entering is positive. So it is plus 20 at an angle 90 degrees. Okay. Okay. Then this is first one. Second one, all the elements with I2. What are the elements with I2? 4 ohms plus J2. That is minus J2. That is 4 plus of minus J2. That is 4 minus J2. Again minus J2. It will be I2. Okay. So it will be 4 minus J4. Generally it is for I2. Now in 4 ohms only I2 is flowing. But in the capacitance, these two capacitance, one capacitance I3 is flowing, one capacitance I1 is flowing. So minus J2 that is I3. That is minus opposite to the I2. So minus of minus plus. J plus J2 I3 it is. Now here also opposite. So minus of minus plus J2 I2. So like this the equation will come. See here 4 minus J2 all the elements 4 minus J2 I2 minus of minus J I1 minus of minus J2 I3 plus 20 because current is entering plus 20 at an angle 90 degrees. This is a second loop. Already you practiced this loop equations many times. So no confusion in it. Now coming to the third loop. What are the elements in this third loop? 1, 2 and 1 current elements. So I can write directly I3 is equal to 5 at an angle 0 degrees. No need to write any equation there. Because the I3 is already equal to 5 amps. So the equation is I3 is equal to 5 at an angle 0 degrees. I3 is equal to 5 ampere. Plus. So now thus I3 substitute in equation 1 and 2, then you will get I1 and I2 also. So that's it. You will get the answer. So for mesh 3, I3 is 5 ampere. Substitute in the above two equations. So substitute I3 here 5. That is I3 is 5. That is 5 ampere. So it is J50. So minus J50 it is. So it will go this side. It will become plus J50. Some other side item. Now here only it become I1 and I2. Separate the I1 and I2 first equation. That is 8 plus that is 10 minus 2 how much? 8. So 8 plus J8 I1. Next minus of minus plus J2 I2. Now it is J into 10 times 5. J into 10 times I3. What is I3? It is 5. So it becomes 50J. It become now we can put on other side. That is 8 plus J8 I1 plus J2 I2 equal to J50. This is one equation to make a matrix. Now it is easy. Now coming to the second loop equation, substitute I3 equal to 5. Where is I3? Here. I3 when you substitute here 5, 10 it will be J10. Now what is 20 at an angle 90? How can I write 20 at an angle 90 in terms of J? It is a J20. 20 at an angle is nothing but a J20 it is. Because if you want into a rectangular form, J20 at an angle 90 degrees, it is nothing but J. 90 degrees is nothing but j it will come. Okay. So 20 cos 90. What is cos 90? Okay. That is real part. 20 sin 90. What is it? Sin 90. 1. So 20 will be there. The j 20 sin 90. It is a imaginary part. So here, see here. Now I can rearrange this one for I2 format. Yeah. 4 minus J4. That is J minus J2 minus J2. Okay. 4 minus J4 I2. Now it is I1. It is plus minus of minus plus J2 I1 plus plus J2 times I3. That is 5. That is 10. 10 I3. That is 5 into 2. 10 it will become. Now I took this 20 this side. So minus 28 at an angle 90 degrees. Now 28 at an angle 90 degrees nothing but J10. J20. J20 as it is. Now this J into J2 times 5, it is 10J. I take this side minus J10. So the Jama it is minus J30. So arrange this 2I in the left side and I2 on the right side. It becomes J2I1 plus 4 minus J4I2, which is equal to minus J20 minus J10, which will be minus J30. Now write in the matrix one. Where is the first equation? This one. So 8 plus J8 and J2. 8 plus J8 and this J2. Sorry, this J2. Now second equation. J2 I1 and 4 minus J4 I2. So second equation. On the right hand side, J50 is there. This is on this one, first equation due to, and minus J30 is the second one. Now solve for the determinant delta. Then we have to solve for the determinant delta 1, delta 2. So delta, how will find matrix delta determinant? That is multiply diagonal this one minus diagonal multiplication this one. So what we will get? We will get this one. 8 plus J8 multiplied by 4 minus J4. So what we will get? Minus J square. J into J2 into J2. What is it? J square times 2. What is J square? It is minus 1. J power 2 is minus 1. So minus of minus, it is plus 2 it will become. So 8 into 8 4s are 32. Then 8 4s are 32. So 32 minus J32. Then again 8 4s are plus J32 minus J square 32. Minus J square 32 plus this J square is nothing but minus 1. Minus of minus plus. That is 4. From where this 4 is coming? Okay, it is 4. Sorry, it is not J square, 4 it is. Not 2 into 2, it is 4 it is. Okay, so it is 4. J square is minus 1 minus plus this. Now this minus J32 plus J32 cancel out. Now what remains here? J square. So J square, what is again J square here? Minus 1. So minus of minus plus. So we have 32 plus 4. How much? 68. So the 68 is here. So in this way also we can write. In this way also we can find. So we got delta now. What is the delta? 68. Now what I need? Directly I0. You need I0. What is I0? Is nothing but minus I2. So find I2 only. No need to find I1. Time waste, right? So just find I2. That is our answer. So find I2, then make it negative. Then it is the I0. So what is I2? Is nothing but second determinant. We have to make it. What that is? Remove this J2 and 4 minus J4 and keep minus J50 and minus J30. Okay. So remove that second column with J50 and J30 from this right hand side. Okay. Now determinant 2 is nothing but diagonal multiplication minus other diagonal multiplication. So diagonal multiplication will be 8 plus J8 multiplied by minus J30 minus J square 2 into 50. So 2 into 50 it become 100 and J square is minus 1. Minus of minus plus. So this plus 100 it will be there. Now 8 into J30 it is minus J240. Now J square it become minus J square and 8 into 30 again 240. So here again J square is nothing but plus minus 1 minus of minus plus. So plus 240 here. Plus 240 plus 100. How much? 340. So plus 340 minus J240. So plus 340 minus J240. Now convert it into polar. It become 416.17 at an angle minus 35.22 degrees. So like this, we got delta 2. Once we got delta 2, what is I2? I2 is nothing but delta 2 taqsim, that is divided by delta. So we know the delta and we know the delta 2. So find the I2. So I2 is nothing but delta 2 divided by delta, that is 416. This is 0.17 minus 35.22 degrees divided by, it is real number 68. So direct, not in polar, right? So directly we can divide 68 for 416.17 divided by 68, you will get 4.12 at an angle same, no change, that is minus 35.22 degrees. But this is in which form? It is in polar form, that is frequency domain form. But generally in which form we need? Sinusoid form, we need the answer. So convert this polar form into sinusoid. What is the equation? When you convert this polar to sinusoid, what is the equation? If we have Vm at an angle of theta, so what is the sinusoid of it? Vm at an angle, it is Vm. Vm is nothing but 6.12. Sorry, Im is 6.12 at an angle minus 35.22. This is theta. Let's take theta, that is. So Im, it is theta. Then what is the sinusoid equation generally? What is the sinusoid equation generally? It is nothing but I cos omega t plus theta. This is the sinusoid equation. I cos omega t plus theta. So just what is Im? 6.12. Cos omega t as it is plus, but here minus is there. So minus 35.22. Okay, it's not given. Oh, no problem. We can convert this one. So now again, I0, I2 is not the I0. What is I0? It is minus I2. So minus 6.12 here, minus 6.12 at an angle minus 35.22 degrees. So take that minus 2 inside. What we have to do? Take the outside minus into the polar form inside the degrees. We have to just add 180 degrees. Add 180 degrees. So 180 minus 35.22 degrees. It is nothing but 144.78 degrees. Now convert this into phasor. It's nothing but 6.12 cos omega t plus 144.78 degrees. Yeah.
Because it should be minus 6.
Yeah, minus only. But that minus is taken inside. See the angle.
Oh,
Add 180 degrees. Add 180 degrees inside. Okay, here one step missing. Don't worry. Okay, angle is changing here. Here minus is going to inside. So this minus 35 will come 180 plus 180 minus 35. So it become 144 plus. Okay. So like this we have mesh analysis. Now coming to the superposition theorem, then source transformation we will finish today. In next class, that will be last class, it will finish Thevenins and Nortons. Power, instantaneous power, average power, we will skip for this subject. Okay. Okay, superposition theorem. What we have to, generally superposition theorem, what we will do? If we have many sources in a circuit, take one source at a time, make other sources off. Off means make zero. Open circuit the current source, short circuit the voltage source. That's it. And later on, keep different voltage source or current source and solve the equation and add all together. That is your superposition. So since AC circuits are linear, the superposition theorem applies for AC circuits also. In the same way, it applies in the DC circuit. The theorem becomes important if the circuit has source operating at different frequencies. Here the one logic is here. Sometimes the voltage source is there with sine 4t. One voltage source cos 4t. Another voltage source is cos 5t. Both are different frequencies. So we have to take care of it. Okay, while calculating the frequency domain from the sinusoid to frequency domain, these frequencies you have to take care. Okay, 5t, 4t is different. So the value of the inductance, capacitance, their reactance will change. Inductance, reactance, capacitive reactance, the value will change because of these frequencies, omega t. Omega is frequency, right? In this case, since the impedance depends on frequency, we must have different frequency domain circuit for each frequency. So superposition, we know that one source at a time. So one source, one frequency will be there. So calculate as per that the phasor. Then second source, superposition, second circuit. Check the frequency and convert into phasor. So like that we have to solve. We'll check. The total response must be obtained by adding the individual responses in time domain. In time domain itself, we have to add it because already they are converted based on
their individual frequency, right? Not separate, not in one frequency. They are already calculated with different frequencies. So we can add in the time domain, in frequency domain only. Once it is added, then you can convert it into sinusoid. Okay, one example is there. It is very important. Be careful. Find V0 of the circuit using superposition theorem. What is the circuit? Check here. Where is the V0? Here. So the voltage across this resistance, we know, we want with superposition theorem. How many sources we have? How many we have? Three. How many voltage? Two. How many current? Again, another question. How many DC voltage source?
One.
Okay. How many DC sources?
One.
One. How many AC sources?
Two.
Two. In that, one is voltage source AC and one is current source AC. So AC means frequency will come. DC, no frequency. So one step we don't have any problem. Normal superposition theorem we can apply with the DC. Okay. Remaining two, we have different frequency here. Sin phi t, cos 2t, right? So we have to be careful while calculating their impedances, while calculating their reactances. Okay. Now, because the circuit operates on three different frequencies, omega is equal to 0, that is for the first source, 5 voltage, and that is for the DC voltage source. Then one way to obtain solution is to use superposition, which breaks the problem into single frequency problem, so that V is equal to V1, V2, V3. So V is equal to when I will consider this as a V1 and I will consider this as a V2 and I will consider this as a V3, means steps. Okay. So V1 is due to 5 volts when it is there. V2 is when 10 cos 2t is there. V3 is when current source is there. So we will find the V0 there. So V0 is nothing but V1 plus V2 plus V3. So let's go. So where V1 is due to 5 volt DC source, DC voltage source, and V2 is due to 10 cos 2t volts AC source, and V3 is due to 2 sin phi t ampere current source. So these are the what we assume. Now to find V1, so let's start with the V1. Okay, V1 means only 5 volts voltage source is there. Remaining is off. So current source, what is the current source? Open. What is the voltage source? Short. Okay, so when it is short circuit and when it is open circuit, how the circuit will behave? 2 Henrys, 1 ohm, 4 ohms, 0.1 farads will be there with the 5 volt system. But another problem, when DC is there, how the inductance will act as? Short circuit. How the capacitance will act as? Open circuit. So this is short circuit and this is short circuit. This is open circuit, this is open circuit. So what remains? 1 ohm and 4 ohms are in series. Simple, right?
5 ohms.
Where is the 5 ohms?
Yeah,
5 volts battery, that is. Yeah, total is 5 ohms. But we need V1 here. V1. Only in this voltage we want. Okay. So directly we can run. Okay. As you said, okay, 5 ohms. So 5 ohms, what is the current? I equal to 5 volts divided by 5 ohms resistance. 1 ampere. Right. So 1 ampere is completely flowing. So in this and in this, because they are in series. So what is the voltage here? V1 is nothing but V0, it is V1 in superposition, is nothing but I into R. What is I? 1. What is R? 1. So 1 volt. V1 is 1 volt. Understood now? First is as per DC analysis, very easy for you. Now coming to the second V2. So let's check that one. So now how the current is flowing? In this direction. So the plus minus is opposite. So it is minus 1 volt. So minus V1 it will be. That is 1 volt and V1 will be minus 1 volt. V0 is plus minus here. So V0 which is nothing but minus 1.
Okay, because there's a
Flowing current in this. Current entering or leaving? When current leaving, what is the
from the voltage source.
yeah, from voltage source current is leaving, but current now here as per this plus or minus, it is leaving also. So minus 1. Not plus 1, it is minus 1. So here that's why marked as minus V1 because V0 is in this direction. So which is equal minus V1. So it is plus 1 it will become. If it is V1 it is minus 1. Okay, we will see that one when we substitute. Now okay, this is our circuit what I told you. That is the capacitance is open circuit and here the inductance and the voltage source is short circuit. So 4 and 1 is the summation. the voltage is 1. Now coming to the second circuit, which one is the second? This is one. That is 10 cos 2t we have to consider. This current source open and this voltage source short. Okay, this voltage source is short and this has to be open. Now there will be a 4 ohm resistor, 0.1 farads, 1 ohm resistor and 2 Henry inductance for this source. This is the second circuit. Now directly we cannot solve this one because these are in sinusoid. We have to convert it into phasor. So how to convert this phasor? To find V2, we set to 0 both 5 volt source, that is and 2 sin t current source, and transform the circuit to frequency domain. So how will 10 cos 2t transform to the frequency domain is nothing but 10 at an angle 0, because cos 2t plus theta is not there, plus theta will be there, right? So not there, so 0 degrees. So the polar form of this sinusoid is nothing but 10 at an angle 0. What is omega? 2 radians. This omega t. Omega is 2 radians, which is required for finding the reactance. So next 2 Henries is nothing but J omega L. What is inductive reactance equation? J omega L. What is the capacitive reactance equation? 1 by J omega L. Okay, or minus J by omega L, omega C. So 1 by J omega C, which is minus J divided by omega C also we can say. Okay, so this is J omega L. What is omega? 2 radians. What is L? 2 Henries. 2 into 2, 4. So J4. So the 2 Henries will become now here J4. Now capacitance 0.1 farads. So it is equation is minus J divided by omega C. What is omega? 2. What is 0.1? Yeah. So this become 2 into 0.1. This is 0.2. 1 divided by 0.2. How much? 1 वाहिद तकसीम अशरा सिफर फासला इतने 1 divided by 0.2.
0.1.
10 divided by 2. 5. It becomes 5. Okay. 5. That is J5. It becomes minus J5. Sorry. Because it is J I am taking upwards. So multiply and divide both sides up and down. It becomes J square. It is minus. So it becomes minus up. That is minus J5. Omega C is nothing but 0.1 into 2. 0.2. 1 divided by 0.2 is 5. So this is minus J5. Now these three we got it. We know we want only 3 items. One, this one and this one. Remaining, this is open circuit and this is short circuit. Now draw the circuit. This is the circuit. This is the 10 at an angle 0 degrees because of this polar form, and capacitance. This is open circuit. Now this capacitance is nothing but minus J5. Already we calculated. Now 2 Henry it become J4. We got it. And because this is open circuit, these two will become in series. So 1 ohm here. Now again 4 ohms as it is, no change. Now this is short circuit. So this is your circuit 2 when source is considered 10 cos 2t. Now we have find the impedance Z. I want Z here only. 4 J5 and minus J5 and 4 I will consider as a Z. Okay, minus J5 is parallel with J4. Minus J5 is parallel with J4. What is the result? Multiply divided by Jama. That is minus J5 into 4 divided by 4 minus J5. So it again convert it into polar, these two, and make it division and convert back into rectangular. It become 2.439 minus J 1.951. There are 2 steps are missing here. What are the 2 steps? We have to convert this. What is this? This is rectangular to polar, and this rectangular to the polar. Then divide it. Easy division. Then convert back into the rectangular. So it becomes 2.439 minus J 1.951. This is Z for only these two combination. These two combination Z. This is as it is. We are not touching that one because we need voltage in resistance. So we should not add with some other items. So just keep it that one. So what happens? All will be in series. Z and this will be in series. Then voltage division rule, we will get the what is the voltage here in V2. Okay, let's see. So this is our circuit. Now by voltage division rule, what is V2 here? V2, what is V2 here? Nothing but, it is nothing but that is voltage divided by total resistance. Voltage divided by total resistance or total impedance as per this one, multiply by voltage. That is voltage is there 10 at an angle degrees divided by total resistance multiplied by at which point we want the voltage, that is 1 ohm. This is 1 ohm is here, okay, multiplied by the voltage 10 at an angle 0 degrees divided by total resistance. This is a voltage division rule. Maybe you forgot, just you can recall. So what is the total resistance now? 1 plus J4, and what is this parallel combination result? Already we have, that is Z. So that Z is nothing but already we have in the previous equation. Join this 1 plus J4 with the Z in the rectangular form, then divide with the 10 at an angle 0. So it becomes 10 by 3.439 plus J2.49, which is equal to 2.498 at an angle minus 30.79 degrees. So now in time domain, if you convert this 2.498 at an angle minus 32.79 degrees, then it will become 2.498 same cos 2t minus 30 point, because cos 2t at an angle theta. So this is now in the sinusoid, from frequency domain to sinusoid. Now V3, last one, we have to get the V3. So V3, to obtain V3, we set the voltage source 0 and transform what is left to the frequency domain. So I think diagram, okay. So frequency domain, the current source is nothing but 2 sin phi t. Convert it at 2 at minus 90 degrees, because it is sine. Because it is a sine, so it is lagging minus 90. 2 sine, generally it is 2 cos omega t is there, then it is 2 at an angle 0, but it is sine, so it is minus 98 will come. Now what is omega? 5. Omega t, this is 5. Now calculate the what is inductance, what is capacitance. So first inductance 2 henries, it will become j omega L. Omega is 5, L is 2 henries, that is J10. Now convert capacitance 0.1 farads, 1 by j omega c. 0.1 into 5 is 0.5, it is 1 by 2, that is 2 it will become. So minus j 2 ohms, we got it. Now see the diagram. So now I convert that inductance to J10. Now I convert the capacitance to minus J 2 ohms. Now where the resistance is there and this resistance is there. Now the current is there, current source is there. Now calculate the what is the voltage in V3. Now before going to that, what we need, these 3 are in parallel, 1, 2 and 3. These 3 are in parallel. Let's see. Okay, Z1. First we will find the Z1, this one. First we will find the Z1, that is minus J2 and 4 are in parallel. These 2 are in parallel. Okay. Now minus J2 and 4 are in parallel. So multiply and divide with summation. Minus J2 multiply by 4 divided by 4 minus J2. That is 4 plus J2 it should be. It is 4 minus J2 because of the minus sign to the J2. Now we again convert into the rectangle polar, and this one and divide it and convert back to the rectangular. It is 0.8 minus j 1.6. Then by current, so we got Z1. This here we got the Z1, we got it, and we got the J10 here and 1 ohm. So because it's a current source, so current division rule will be there. In this Z and 1 ohm, one current will flow, and J10 another current will flow. So what is the current division rule? Current division rule is opposite to the voltage division rule. Equation is same, that is total current divided by total impedance multiplied by other resistance, right? Other resistance, see here. So V3 is equal to I1 multiplied by this. V3 is nothing but I1, by current division rule first. What is I1? Is nothing but J10, other resistance, that is this other resistance, that is other impedance we can say, divided by total impedance multiplied by total current, that is 2 at an angle minus 90 divided by total impedance, that is minus J10, that is this one, plus 1 plus Z. What we got, these 2 in parallel. Z we got 0.8 minus J 1.6. So join these all together and divide with this, you will get some I1. So what is V3? I1 multiplied by V3 is nothing but current is flowing in the same direction. So it is positive only. V3 is nothing but I1 multiplied by 1 ohm. So what we got I1 is nothing but this one. So it is J10 divided by 1.8 plus J 8.4. If we add this everything here is Z, here if we add this, you will get minus J2. What is 2 at an angle minus 90? It is minus J2 because I am taking out converting into rectangular form and sign, minus sign will go to here. So just multiply and divide, you will get 2.328 at an angle minus 80 degrees. So this is 1, and where is it? This is 2, and V1 we got something. What is V1 we got? Let's check. Yeah, V1 we got minus 1. Minus 1 we got. Minus 1 volts. So what is V1 plus V2 plus V3? Okay, now we got V3. Okay, V3 in the form of sinusoid, 2.33 sine phi t 10 degrees. Why it is 10 degrees? Because it is minus 80. So it is sine we want. So in the sine form we want. Because it is in cos form, it is minus 80. Convert this into sine form, because this equation V2 is in cos form. So convert it into sine form. Then it is 2.33 sine phi t plus 10 degrees. Then let's see, substitute. What is all these equations substitute? It is V1 plus V2 plus V3. Okay, minus 1, 2.498 cos 2t minus 30, 79 degrees plus 2.33 sine phi t plus 10 degrees. This is your final answer. In sinusoid, we have to add, not in the frequency domain. Just you have to add it. No need of any solution here. No need of any, because one is in 2t, one is in phi t. How can we get? We cannot get the result. Okay. So like this, we have to, we got the first one with only DC voltage source, and second one with the AC voltage source, and the third one with the AC current source. So V1 plus V2, V3, see minus 1 is here, minus 1. Okay. So this is our superposition theorem. So last topic. Yeah, I have to finish that one also. Let me finish. Okay, source transformation. What is source transformation? Converting voltage source to current source and current source to voltage source. So when there is a voltage source in series with a resistance, now here AC impedance, it is R plus JX, JX or XC, we can know. So convert this into current source is nothing but current source with this ZS will become in parallel. ZS will become in parallel. This VS will become IS. Now this ZS will come into parallel. How this IS is coming? Is nothing but Vs divided by Zs. That's it, simple. The same, V by R is nothing but I. So like that. Now, okay, source transformation in frequency domain involves transforming a voltage source in series with impedance, not resistance. Impedance to a current source in parallel with impedance or vice versa. This is called source transformation for AC. In generally frequency domain or AC, both are same. Okay. The question may change here. I can ask in AC or frequency domain. Source transformation in AC is dash. You can put in this diagram. Okay, we go from one source type to another. We must keep the following relationship in mind. Vs is equal to Zs into Is. Is is equal to Vs by Zs. That's it. Now one example is there. Quickly we'll see. Very small one, not the big one. See here. Calculate Vx in the circuit using the source transformation method. So where is the Vx? In this 10 ohm resistance, we want the voltage by using source transformation method. We have many methods, node analysis, we have mesh analysis, we have, and yeah, anyone you can use, but it mentioned source transformation. So first what we have to see, where is the voltage source or current source. So we got one voltage source, and then what we have to see, a resistance in series to that voltage source we have to see, or a impedance we can say. Okay, so there is a resistance is there. So directly these two can be converted into current source. How? V multiplied or divide. V divide by Z. Here Z is only R is there. So 28 an angle minus 90 divided by 5 directly. So the current will become 4. 4 at an angle minus 90 current source. In parallel, 5 ohm resistance will come. That is source transformation of voltage to current. Check it. See, Is is nothing but J4. Why J4? Because minus 90. Minus 90 is nothing but minus J20. Now convert into current source divided by 5. So 20 divided by 5, 4. So minus J4 current source, and this series resistance will become in parallel now. Remaining all same. Remaining all are same. I didn't touch this one because only these two are converted into current source. Now next, these two will be in parallel. Okay. Now what we have to do next? See. So we got Is is minus J4 ampere and 5 amps is the in parallel. Now next, the parallel combination of 5 ohm resistor and 3 plus J4 impedance gives. So Z1 we need. Here again I need a Z1 here. Once I got the Z1, I can convert back this IS and Z1 to voltage source with a series. So it is easy. So this 5 multiplied by 3 plus J4 divided by 5 plus 3, 8 plus J4. Now divide this, then you got 2.5 plus J 1.25. So this is 15 plus J20, 8 plus J4. Now convert it into polar form. This 15 plus J20, it will become 25 at 53.13 degrees. Convert this 8 plus J4 in polar form, 8.94 at 26 degrees. Then divide it easy. 25 divided by 8.94, 2.8. 53 minus 26, 26 degrees. So then you can convert back into rectangular form, no problem. That is 2.5 plus J 1.25. Okay, now we got Z1. So once we got the Z1 here, then this Z1 and IS can be converted back into the voltage source and a series impedance. 2.5 plus J 1.5, what we got here. Then how this Vs got it? How can we got Is multiplied by Zs? So Is divided by Is multiplied by Z1. Is multiplied by Z1. That is Vs is nothing but Is multiplied by Z1. What is Is? Minus J4. What is Z1? We already got it. 2.5 minus J 1.25. Multiply this, you get 5 minus J 10 volts. So this is your voltage source and this is your Z1, what we found from this parallel. Now the remaining is untouched. So remaining is same. Now what we need? We need a Vx, voltage here. So for that, voltage division rule. Voltage division rule is nothing but voltage, complete voltage divided by total resistance or total impedance multiplied by that resistance or that impedance, right? That part only. So that part is 10 ohms only because it's a resistance, easy. 10 ohms is the resistance where we want the Vx divided by total impedance. That is 10, what are they? 10 and 2.5 plus 4 plus J to 1.25 minus J 13. All are there included here. Now multiplied by total voltage. What is total voltage? Minus 5 minus J10. So multiply and divide, you will get 5.519 at an angle minus 28 degrees. Now is it finished? So how it is you are getting? I just calculated here. Okay. So 5.519 at minus 28 degrees is your final answer. Okay. This is your source transformation. So in next class we will go for the Thevenin's and Norton's theorem, inshallah. Okay, let's start. So previously we studied nodal analysis, mesh analysis, and now source transformation we studied, and what we call superposition theorem we studied. The last topic in the analysis is Thevenin's and Norton's equivalent circuits. Then we go for the power. Okay, let's start with Thevenin's and Norton. So we know that if any linear circuit is given like this, then its Thevenin equivalence between terminal A and B is nothing but V Thevenin's is the voltage source in series, Z Thevenin's is the impedance. That is in DC we have V Thevenin's voltage source and R Thevenin's is the resistance generally. But here because AC it is Z Thevenin's, impedance will come here. Same Norton's. Norton's will be current source and Zn. Zn is nothing impedance. Norton's impedance is in parallel. So this is in series, this is in parallel. By source transformation also we can do, no problem. So the Thevenin's and Norton's theorems are applied to AC circuits in the same way as they are in DC circuits. Same way, no other extra steps. Same steps we can follow. The only additional effort arises from the need to manipulate complex numbers. Means impedance is a complex number, resistance plus a reactance. So we have to convert it and we have to multiply, change to polar, then we have to convert it back. So this way one more step will be there. That's it. Method is same. The frequency domain version of Thevenin's equivalent circuit is shown in figure. This one, where the linear circuit is replaced by a voltage source in series with a impedance, as I discussed. Now same, the Norton equivalent circuit is illustrated where the linear circuit is replaced by a current source in parallel with the impedance, Norton impedance. Now keep in mind that the two equivalent circuits are related as just in source transformation. So these two can be transformed easily by using source transformation, where VThevenin is the open circuit voltage and IN is the short circuit current. This is a short circuit current is nothing but IN, and this open circuit voltage across A and B is VThevenin. So ZThevenin will be equal to Zn. So VThevenin is equal to Zn is equal to multiplied by IN. So Zn multiplied by IN. So based upon this, ZThevenin is equal to Zn. So like RThevenin is equal to R near Norton's in the DC circuit. Same principle. Okay, one example we have. Example, find the Thevenin equivalent circuit figure and terminal A and B. So this is the terminal A and B. We want the Thevenin's equivalent circuit. So what we need? We need Thevenin's voltage, and we need a Thevenin's what we call impedance, not the resistance, impedance we need. And luckily all are in the which form it is, these are in frequency domain. 4 ohms, J is there means frequency domain. Okay, if it is given inductance with henries and capacitance with farads, and this in the sine or cosine terms, then it is a time domain method, cosine sinusoid method. So then what happens? We have to convert. In another step we need to convert it into frequency domain, to convert like J3 and J4. We have to convert it. But luckily already they are given in frequency domain itself. So these are now in complex numbers. So what we will do first, for finding the VThevenins and for finding this one or ZThevenins. So we need first node 1 and node 2. What are the currents? Applying KCL, Kirchhoff's current law at node 1 and node 2. So these two will join, 2 minus J4 will join as a Z here. Now 4 plus J3 is join as another Z1, and this is Z1 and this is Z2. So this is one impedance, this is another impedance. Now this is dependent source 0.5 I0, and we have a current. Now at this node, what are the currents entering? 15 amperes, because it is 15 at angle 0. So 15 amperes only we can take. 15 is entering at the node 1. What are the leaving? It is 0.5, because the current is the same, because it's open circuit. So current will go from 4 plus J3 to 0.5 I0 and come back to here. So this is 0.5 I0. The current in this impedance is 0.5 I0, and I0 already here given. I0 is there. So I0 is outgoing, and 0.5 I0 is also outgoing. So what we will have? 15 is equal to I0 plus 0.5 I0. So sum it and find the I0. Directly you can find I0. So 15 equal to I0 plus 0.5 I0, which will become 1.5 I0. So I0 will be 15 divided by 1.5, which is nothing but 10. Just taqsim hada. 15 taqsim 1 nus 10. So we got I0 now. Very good. Now we need at node 2. Node 2. But node 2 no need to go, because it's a open circuit here, because there is no node 2 here, because it's a open circuit. This become a one loop, because this is a open circuit here. A and B are not there. There is nothing here. So what happens? These two will become in series, right? Series means this is in series with the current source. So we become a loop here. One loop will come here. So what is the loop here? In this impedance, I0 voltage we need. I0 multiplied by Z. That is, and how the direction I chosen in this form. So it will be minus, because this and this direction is opposite. So minus I0 multiplied by 2 minus J4 plus same direction. This is our assumed direction, and this direction is same. So plus 0.5 I0 multiplied by 4 plus J3. 0.5 I0 multiplied by 4 plus J3 plus VThevenin, because here what is the voltage is there, it's coming at this node completely. VThevenin is adding here. So equal to 0, because what is happening here, when you find the KVL, this will open circuit. Now VThevenin is the voltage will come here in the loop. So it is VThevenin plus VThevenin, because current is entering the plus terminal. So plus VThevenin. Now find the equation. With the now we can equate VThevenin is equal to just unknown terms here is only VThevenin, because already I0 we know what is 10 amperes. So substitute 10 amperes everywhere. Now VThevenin become J55. So VThevenin is now we got J55 directly. And thus the Thevenin voltage is equal to what is minus J55? Minus means it will go J means 90 degrees. Minus will go means minus 90 degrees. So 55 at an angle minus 90 degrees is your VThevenins. Another way also we need what we need? We need the Z-Thevenins. For Z-Thevenins, what we used to do in the DC analysis, when there is a dependent source is there, we apply some voltage at open circuit terminal, or we apply some current at open circuit terminal A and B. So same thing we will do here. For finding the Z-Thevenins, we had if no dependent source is there, just we have to open circuit the current source and short circuit the voltage source. We can find the Z resistance or impedance directly. But here dependent source is there. When there is a dependent source, what we have to do? We have to give some voltage or current at open circuit terminals A and B. Same thing I will do. See here, I am applying at these two terminals A and B, which is open. I am applying a current source IS. I am assuming that one with 3 at an angle 0. You can assume here 1 volt, 1 ampere, 2 ampere, anything. But as per experience, I am applying based upon seeing this for division. It will be easy. I am taking 3 at an angle 0 degrees current, so that I can find the Z-Thevenins. So to obtain Z-Thevenins, we remove the independent sources. That is, this is open circuit, and this we cannot remove because it's a dependent. So we open circuit. Now this will be in series. Now this will be there. Now we have to apply here some current source. Due to the presence of the dependent current source, we connect a 3 ampere current source. Why 3? 3 is an arbitrary value chosen for convenience only. Okay, a number divisible by the sum of the currents leaving at the node. Yeah. What is the current I0 and 0.50? It is multiplication with the 3 is easy, division and summation. That's why I choose 3. So as shown in figure B. Okay, now apply KCL, Kirchhoff's current law at node here, because this A node and this is another node. So what is the 3? What is the 3? This is entering. Current is entering here. Now leaving currents are this and this. What is this? I0 and 0.5 I0. So 3 equal to I0 plus 0.5 I0, because current entering IS, that is 3 amperes. We already know here 3 amperes. And leaving currents are 0.5 I0 and I0. So add it 1.5 I0, and 3 divided by 1.5, it is I0 is 2 amperes. So we got I0 now. Now we need what we need? Vs we need. Once we know the Vs, Vs divided by Is, it's nothing but Z Thevenins. Okay, applying KVL. So apply the KVL to the outer loop because it is open circuit. So we have to apply the KVL in the outer loop. So Vs will be is equal to this. Vs is equal to same voltage will be applied the summation of these two. What is the voltage here? This voltage is nothing but the summation of these impedances multiplied by I0, right? Voltage is nothing but IR. So I is I0, and what is these two? These are in series. So I0 multiplied by 4 plus J3. This is this one, and 2 minus J4. 2 minus J4, second one. So rearrange this one. I0 already we know 2 amperes. Now if you take this 4 plus y 6 and J3 minus J4 minus J. So it is Vs, we got it. Now once we got Vs, so what is Z Thevenins? Vs divided by Is. What is the Z Thevenins across A and B? It is nothing but V Thevenins, that is which is equal to Vs, that is Vs divided by Is. So Z Thevenins is nothing but Vs divided by Is. Already we know Vs 2, that is 2 into 6 minus J divided by Is. Is is nothing but 3. Is is 3. Don't take I0. Is we have to take. Is is 3. So 2 multiplied by 6 minus J divided by 3. It is nothing but 4. 3 2 is 4. Yeah, 4 and 1 by 3 is nothing but 0.667 ohms. So this is your Z Thevenins. So like this we have to find Z Thevenins and the V Thevenins. So this is about all the analysis we finished. That is node analysis, mesh analysis, superposition theorem, source transformation theorem, and Norton's and Thevenin's theorem we finished. Any one will come in the final exam from this. Okay, power is not necessary for the exam, but it is needed for your future subjects. So just listen it so that in future it may be useful. Okay, I will not ask power in the final exam. Okay, instantaneous and average power. Power is most important quantity in electrical utilities or electronics and communication system. These are you are studying in the future subjects. Electrical utilities, electronic components you are studying, semiconductors, and what we call computer aided design. Many things you are studying where we need the average power and instantaneous power. Because such system involves transmission of power from one point to another. From one point to another, what is the power we have to know? Maybe AC, maybe DC. DC already we studied. So AC we have to see. The most common form of the electric power is 50 or 60 hertz AC power. So in India and what we call British, we have 50 hertz frequency power, and US and Saudi Arabia and complete Middle East, we have 60 hertz power source. Okay. The choice of the AC over DC allowed high voltage power transmission from power generating plant to the consumer. So the choice of AC over DC. Generally DC if you transmit from the power generating to our local our means our utility, then I square R, the resistance will be high, and I square R will get more power loss, waste of power will be there. So that's why they will convert into AC and AC will be transferred there.
What is the difference between 50 and 60 hertz?
Yeah, it's only the design concept, just the design concept, not this one. And 50 hertz they have 110 volts, and 60 hertz, 50 hertz we have 220 volts and one single wire, and 60 hertz we have single wire 110 volts. If you have two wires, 220 volts. Both are same, 220 only. But single wire we have 110 volts in 60 hertz. Okay, Jama to 220. But in 50 hertz, only one wire we have high voltage, 220 volts, and Tani volt is neutral, 0. So Jama 220 only. So they have its own advantages, its own disadvantages. Don't worry. 50 hertz generally we tell more heat will come. In the 60 hertz they will tell power efficiency is good. So like this, they have their own advantages, they have their own disadvantages. So both are acceptable. It's not different. Okay, now come the how to find the equation. Now we know that sinusoid and this is a passive linear network. That how the V of t and I of t is getting as a power. Power is not V into I, voltage into current. But here V of t means time domain, and I of t also time domain. You have to multiply that one, which have a cosine terms, cos, sine, with a phase angle, which is there. So we need to have a integration and a differentiation. Both you have to do it. So let's see. The instantaneous power P of t absorbed by element. So we are this is a source and this is the element, or we call load, we can say, or element we can say. So where the power is coming to absorb it. Okay. So the instantaneous power P of t absorbed by an element is the product of instantaneous voltage V of t across the element and the instantaneous current. So V of t and I of t is multiplication, nothing but power absorbed by this linear network. Source is this one. Source means maybe voltage, current. Source this one. Generating station we can say. Okay, assuming the passive sign convention means it's moving out from the source to what we call element or load, we can say, passive convention. Now P of t is nothing but V of t multiplied by I of t. This is a multiplication. The instantaneous power in watts. Power always units in watts. Is power at any instant of time. At any instant of time, how much is it is absorbed. Consider the general case of instantaneous power absorbed by an arbitrary combination. This figure is explaining the circuit element under sinusoidal excitation. So next, what is the equation? Let the voltage and current at the terminals of the circuit is V of t. Generally, how it will be? It is Vm cos omega t minus theta. Same I will be Im cos omega t minus theta. But both theta cannot be same. So that's why I measure voltage with theta subscript V, voltage, that's one. And I will measure theta I, means angle for the voltage, angle for the current. See? So V of t is Vm cos omega t plus theta V. It can be plus or minus, it depends. So theta V is nothing but related to voltage. What is the phase angle? How much it is lagging, how much is leading, that depends. Im is for delta theta I. But the remaining is same. Okay, cos and cos. Now multiply. Vm and V and I we have to multiply. Vm and Im are the amplitudes, maximum peak values, sinusoidal. What is the maximum amplitude? Sine, it is sine and cosine is there. Na? So the maximum value how much? and theta V and theta I are the phase angle of the voltage and current respectively. From the zero, how much phase angle it is there. Now the instantaneous power absorbed by the circuit is V and I multiply. So it is given by P of t is equal to V of t and I of t. So Vm Im. So Vm Im multiplication. Cos omega t plus theta V, another multiplication, and cos omega t plus theta I is another. So this is your. Now we have to solve this one. How this is form of cos A plus B multiplied by cos. This is form of how it is. Cos A multiplied by cos B. A is nothing but omega t plus theta V and B is omega t plus theta I. Cos A, cos B. What is the result in the trigonometry? Cos A plus B minus cos A minus B. Right? Check here. Half I think. Cos A cos B is nothing but half cos A minus B plus cos A plus B. This is the trigonometric equation. I will not go to the in deep after that one. You have to just by heart this one. Cos A B is nothing but half cos A minus B. You can rearrange this one also, no problem. Cos A plus B plus cos A minus B also you can write. Okay, but for the solution, I just rearrange this side and this side. Cos A minus B plus cos A plus B. So now I can rearrange this one with this formula. Now, what happens? Vm Im as it is, no changing. Cos, what is A here? A is nothing but omega t plus theta V. B, omega t plus theta I. So substitute here omega t plus theta V minus omega t minus theta I. So omega t plus and minus. So cancel out. So what remains here in the first part? Cos theta V minus theta I. Right? Cos theta V minus theta I will become here. Now here cos A plus B. Omega t plus theta V plus omega t plus theta I. So omega t twice. So 2 omega t plus theta V plus theta I. So it will come like this. See here. So it become half because this half is coming, and Vm Im same, no change. Now this cos A minus B, it become cos theta V minus theta I because omega t will cancel out. So theta V minus theta I will come here in first part, cos A minus B part. In the second part, half Vm Im same, cos 2 omega t because A plus B, because all are in plus. So omega t 2 omega t plus theta V and plus theta I. So this is the final equation of power. Now we can observe the equation. See, this shows us the instantaneous power has two parts. It has two parts. First one, check here. Do you have any t term here in this first part? T means time. Time domain term is there. Any time domain t term is there, like omega t. Omega t is nothing but time, frequency, right? Frequency dependent. So there is no time domain part, first part. Second part, there is a twice the time domain part, right? So this is your real part, and this is, we can say, not imaginary. We can say it is a time domain part. Okay, imaginary will come in complex in frequency domain, right? Okay, real part we can say here because constant. Okay, no problem. Real part always generally constant. We can say constant part. This is a constant part. Once we know the values, constant value will come. That's it. Some it will not come with some what we call sinusoid term. Directly cos 30 we know, cos 50 we know, cos 80 we know. Omega t means we don't know. So here in this part, omega t is coming. So we have to keep in omega t term only. We cannot find. So that's why this is your frequency, time domain part, and this is your constant part. Generally real part also we can say. So now, the first part is a constant or time independent. It is not depending on time. Its value depends on the phase difference between the voltage and the current because it has theta V and theta I. So only the phase difference it is a constant. Once the capacitor and inductor is there inside, then the phase difference of the voltage and current is fixed because that is not varying. So once we know theta V and theta I, it's a constant. Okay, the second part is a sinusoid function whose frequency is which is twice the angular frequency of the voltage current. Twice the angular frequency. It was omega t, now it is 2 omega t. Now, what is there? The instantaneous power changes with time and is therefore difficult to measure. The second part, what is there? It is twice the angular frequency, right? 2 omega t. Now, with time, it is changing every time. Now, so for finding the power, we need a particular time only. We have to dependent, say time dependent, and we have to need that at what time you want the power. Okay, at 12:40 a.m. I want the power. Then it is different. At 1 p.m. I want the power. It will be different. So a time dependent. Okay. So it is difficult to measure. So generally that's how we go for the average power. So instantaneous power we won't measure. Generally any meters, watt meter, power measured by watt meter. So watt meter we call P into P is equal to VI. This is a watt meter. Whatever the power measuring devices what we have in the market, all are measuring average power only, not the instantaneous power. All are average power measurement. This is a general knowledge question for your HIAS exam or Jahazi exam. Instantaneous power we cannot measure because we need at a particular time. At what time you want the power? It is always changing. Complexity will be more to find that one, and we don't have such device. If you want, then having the devices we need a oscilloscope type where instantaneous power will come continuously. It will monitor. Oscilloscope, did you see the oscilloscope? Oscilloscope where the waveforms will show. So in that we can measure instantaneous because it's continuous waveform is showing there. But watt meter is a physical device. So only it can have a multiplication factor only. So only average power it will give. So the average power is more convenient to measure. So in fact, another method. The watt meter, the instrument for measuring power, responds to the average power only. Okay, the average power in watts is average of the instantaneous power over one period. Over one period, it is an average power only. Means the second part we are deleting. First part only we are taking. Okay, thus the average power is given by another method to calculate the power. One at from the 1 by t over a time period from 0 to t at p of t. So apply. Now generally at half of the time we will take it, not more. Okay, now half of the t at half Vm Im cos theta v minus theta I dt and half Vm Im cos 2 omega t plus theta v plus theta I. So this is the part what we find in the previous slide. Now we are integrating it so that how the power is coming we can say. So now if you integrate this one cos theta v minus theta I, what we will get? There is any t term? No t term, right? Only we have 1 by t 0 to t dt. Now here we have cos 2 omega t plus theta v plus theta I. Now the first integrand is constant. This is the first one. The first one it is a constant. There is no t term here. So multiply. There is no t means what it will come? Capital T it will come. So capital T when it is coming after the integration, t and this t will cancel out. So what remains? Only half Vm Im cos theta v minus theta I only it remains. Now in this part the depends upon the time. Okay. So and the average of the constant is same as the constant. Average of the constant is same as the constant integral when you take it. Second integral is a sinusoid. This is a sinusoid one. Cos will become now sine. Then big equation will come. We are not going in that. Just we concentrating on this. So it becomes same half Vm Im cos theta v minus theta I only it will come. We know that the average of sinusoid. So what happening to this second part? Average of sinusoid. Its period is 0 because the area under the sinusoid during the positive half cycle is cancelled by the area under it during the following negative half cycle. Now how is the sinusoid means? One maximum then go to 0. Again negative maximum go to 0. So over a period we are finding over a period, right? 0 to t by 2 from t by 2 to t over a period. So up to t by 2 okay we got some power. Up to again t we got another power. So from 0 to t, what's happening? The power is positive and then power is negative. Both are cancelling out. So the instantaneous part on the second part is 0. Yeah, and for a period, I'm telling. At a particular time, okay, power is there. But for a period, we cancel each other. Positive side and negative side both cancel each other. So what remains? Constant part only remains. So average power only remains. So like this also we can explain. First method is okay. Second method is integration. Okay, so what remains is P is equal to half Vm Im cos theta v minus theta I. This is the average power. Note that P of t is time varying while P do not dependent on time. Previously, what the symbol small p of t. Small p of t was the equation, right? Now the symbol is capital P. Capital P is not the instantaneous power, it's a average power. The name itself tells. Previously, check the previous. See, PFT. Right? Now we are cancelling out this one, then only this remains. So that I am changing this P of T to capital P only, because I already integrated and that positive part, negative part cancel out. So only P remain. So P of T is the instantaneous power, capital P is the average power. These two names you have to remember. Okay, note P of T is time varying period. Okay. Now, to find the instantaneous power, we must necessarily have V of T and I of T in time domain, and we have to integrate it. We have to apply many things. Okay, but we can find the average power when voltage and currents are expressed in time domain. So in time domain, that is we have, then we can convert it into frequency domain and find the direct average power. No need to go sinusoid. Directly convert it into a frequency domain and find the average power. This is the advantage. The phasor form of V of T and I of T, how can we write? What is V of T equation generally? Voltage equation? Vm cos omega T plus theta V. So how can I write in this Vm cos omega T theta V in the phasor form? Vm at an angle theta V. I of T is nothing but Im cos omega T plus theta I. So how can I write in phasor form? Im cos Im at an angle theta I. So like this we can write. So V is nothing but Vm at theta I. V and I is nothing but Im at theta I in phasor form, because this theta V, theta I will coming from the original equation cos omega T plus theta V and cos omega T plus theta I. Now P is calculated using another method I am telling, using using phasor form. Just now what we studied only using which form? Time domain form or sinusoid form. We calculated V of I multiplied by I of T, V of T multiplied by I of T, then integrated. So many things we did. Now easy method I am telling how to explain. Explanation, two methods I am explaining. Now frequency domain, how we can go? Phasor form. We already converted into phasor form. So what is the phasor form? We notice that half Vi. So it's nothing but what is V and I? Vm and Im at theta V minus theta I. What we find there? Half Vi, right? Power is equal to half Vi, right? Half Vm Im cos theta V minus theta I. So we can write half Vm Im at an angle theta V minus theta I. Now I can write this in the previous equation. How can I write in the complex term? Because this is in which form it is? Polar form. Convert this polar form into rectangular form. Convert this polar form into rectangular form. What is that? Cos and sine will come here. So half Vm Im as it is. One is cos term, one is sine term. So cos theta V minus theta I plus j sine theta V minus theta I. Converting into polar to rectangular. Sorry. Now we recognize that the real part of this expression. Now here it is coming real and imaginary. Okay, the previous one is the constant one. Here is the real and imaginary will come. Real part of this expression as the average power P according to. So real part is this one. Half Vm Im cos theta V minus theta I. Right? This is your average real part. Okay. Now thus P equal to half of the real part of V into I, which is nothing but this one, cos theta V minus theta I. That is half Vm Im cos theta V. We got the same equation as the previous, right? Which equation it is? What we find in the time domain, right? Vm Im cos omega theta T theta V minus theta I. We find there by integration, by multiplication. But now with the phasor form, 1, 2, 3 steps we got it. With there we got many steps. Here only 3 steps we got it. Same equation. That is half real part of Vi, which is nothing but your average power. Because we are neglecting the imaginary power. Imaginary times we are deleting. So this is the equation what we got. So last slide for the consider two special cases when the voltage and currents are in phase. Now theta V and theta I. When will be in phase? What is in phase means? Means voltage and current starting at the same point. Voltage, waveform of the voltage and current is starting at the same point. It's nothing but in phase. Means theta V is equal to theta I. Voltage angle theta is equal to angle of the current. Both are same. Then it is called in phase. Maybe they have some angle. Maybe they may not have angle. But they are must be same. Voltage and current must have same angle. Then it is called in phase. So theta V equal to theta I is called in phase. When it happens? When there is no reactance, there is no capacitance, there is no inductance. That is called in phase. If there is inductance, what happens? Current lags the voltage. When there is a capacitance, what happens? Voltage leads the, or current leads the voltage. Like that. So this implies purely resistive circuit. That is, when theta V equal to theta I in phase is there, though no capacitance, no inductance. So that is called resistive circuit, like DC. If they are having some delay, theta V is not equal to theta I, then some impedance is there or some reactance is there. Maybe inductance, maybe capacitance, we don't know. Or to combination, we don't. So that then what it become? Theta V minus, what was the equation? Half Vm Im cos theta V minus theta I. So when theta V and theta I are equal, what happens? Theta V minus theta I, 0. So cos 0, 1. So this equation will come, half Vm Im. Okay. So how it is now? Half Vm Im, which is equal to half Im square R. That is, convert this into resistance. What is replace V with I? So it's nothing but Im R. That is Im R. So this now become Im square R. Okay. So then it is half mod of square R, then resistance R. This is your power, average power. If it is pure resistive. Now it is a multiplication. It is these two. Okay. Now equation shows that purely resistive circuit always absorb power. Now half I square R is there. Means what? There is some power is there. Means it is absorbing. Okay. Now we see opposite side. When both are purely inductive and purely resistive, we'll see. We know the equation of the power. What is that? V half Vm Im cos theta V minus theta I. Now purely resistive, purely inductive. There is no resistance. Let us take purely inductance. What happens? Let's see. Okay, when where theta V is minus theta V is plus or minus 90, we have purely reactive circuit. So when theta V minus theta I, generally it is wrong. This I is plus or minus 90, we have purely reactive circuit. Now half Vm Im cos 90 degrees. What happens? 0. So what it means? There is no power when it is purely inductance or purely capacitance. I already told you. Power absorbed in three passive elements are there. What are they? Resistance, inductance, and capacitance. They are passive elements. Resistance always absorb the power. Inductance never absorb the power. Capacitance never absorb the power. Pure, I'm telling. Okay, I know that in the universe we don't have any pure inductance, pure capacitance, but pure inductance and pure capacitance never absorb. It stores the power. It stores the energy, but it never absorbs the power. It stores it and give back. Whenever needed, it will give back. So is there any power loss? No power loss. Only power loss is in resistance, which absorbs the power. How it will be? It may dissipate heat or something. There is different based upon material. So that's why P average power for pure inductive and pure capacitive circuit or pure reactive circuit, we can say. Reactive means maybe inductive, maybe capacitive, is 0. Okay. Yeah, another 5 minutes. Shows that purely reactive circuit absorbs no average power. Okay. In summary, a resistive load absorbs power at all times, while the reactive load L or C absorbs 0 average power. Okay. So this is the instantaneous power and average power. This is important for your future subjects. For your simplicity, I will not give in the exam. Okay, some 2 examples are there. In 5 minutes, we'll finish. Okay, given that we have T is this much, 120 cos 377T plus 45. This is theta V, voltage. That is voltage angle. Now, I of T is same, 10 cos 377T. That is omega T is same. Omega T is and here same. It must be same. Then minus 10 degrees. It is theta I. So what is the angle difference between V and I? How much is the angle difference between V and I? Anyone? And which circuit it is?
What the difference?
Angle, theta V and theta I. What is the angle difference? Theta V minus theta I. 45
35.
minus.
No, for subtraction.
Yeah, theta V minus theta I. How much?
Theta V.
Theta V is 45. Theta I?
Oh, minus.
Yes, that's the point. Okay, don't say only 45 minus 10. This is 35. Wrong answer.
45 plus 10.
Plus 10. Okay, so how much lag it is there? Plus 10 means what happens here? So 45 here minus 10. So it total 55 degrees. Voltage is plus 55 means it is starting 55 degrees before. Plus 55 means before it is starting. So which circuit it is? Current lags the voltage. Which circuit? Current lags the voltage. Inductive circuit. Means inductance. There is inductance. Current leads the voltage. It is capacitive circuit. Okay. Okay. That's not our question, but general knowledge I am checking. Now, what is our question? Find the instantaneous power and the average power absorbed by the passive linear network. Now, here I want to show with example. Average power and instantaneous power both are same. I am showing here. Check here. P is equal to VI because it's instantaneous. V of t, I of t is in instantaneous. So multiply 120 multiplied by 10, 1200. Cos this equation and cos this equation I multiply here. Cos and cos. Now by using cos A, cos B formula, use it. What happens? Cos A, cos B formula, half cos A plus B plus cos A minus B. Or you can rearrange, no problem. So substitute here in this equation. P is equal to half means 1200 divided by 2, that is half, 600. Now cos A plus B, that is 377t plus 2 times it become. 2 times 377 means 754t plus theta V plus theta I. So now here plus is there. So 45 minus 10, 35 degrees. No problem. Here plus is there. Now here minus is there. A minus B. So 377t and 377t cancel out. 45 degree minus of minus 10, it become plus. So 55 degrees. Okay, 55 degrees now. So cos 755t plus 35 degrees cos. Now substitute. Okay, P of t is equal to 344.2 plus 600. Now here. Now cos 55 we know it. What is cos 55 value? Something will come. So multiply with 600. It is nothing but 344.2. Remaining 600 cos this part. This part is remaining. So this is your constant part and this is your time domain part. Right? So what is the power? This is the power. 344.2. Now another power. Average power is given by half Vm Im cos theta V minus theta I. Don't go for this in this format. Directly, if you know the average power equation, half Vm Im cos theta V minus theta I, it is nothing but half of 120 into 10, that is 1200 divided by 2, 600. Cos 45 minus of minus 10 degrees, cos 55 degrees. Directly if you substitute, it will give 600 cos 55, 344.2. Same it's coming, 344 here. Instantaneous power is also a average power plus some time domain equation. Okay, average power plus time domain cosine term. That's one. So this is your instantaneous and average. Like this you can find. Okay, another example, last example. Find for the circuit shown, find the average power supplied by the source and the average power absorbed by the resistors. So by the resistors, in the resistor, what is the average power and what is the power supplied from this source we need. So the current I is given by, what is I is nothing but directly these two are in series, 4 plus j minus 2 is your Z. Now this is voltage. V divided by Z is nothing but your current. So V is 530 degrees, 4 minus j2 is your impedance, these two. So we will get convert this into polar form, it becomes this, and final will come 1.18 at 56 degrees the current. Now we got it. Once we got the current, we got the voltage, we can find the average power, right? So average power is given by half Vi cos theta V minus theta I. So theta V is now how much? 30 degrees. What is theta I? 56 degrees, right? So half 5 multiplied by current 1.118 multiplied by cos 30 degrees because the voltage theta V and minus theta I 56.57. Now we got some angle here, cos of some angle, some value will come, multiply and divide with 2, you will get 2.5 watts. Average power is 2.5 watts supplied by the source. Now I want to see what is the power in the resistance. Then I can prove that this capacitance won't take any power. That I can prove it. See. Now the current through the resistor is IR is equal to I, same, because all are in series. IR is equal to I, and I already we know 1.118, 56.57 degrees. Okay. Now, and VR is equal to 4 IR. VR is equal to 4 IR. That is 4 multiplied by I. Right. Now 4 into 1.118, it is this much. 4 into 4.472, angle is same. Now the power is nothing but average power in the resistance in half I square R, right? R half VI. VI also okay, I square are also okay, both are same. But we know the V, we know the R, we know the I. So we can find directly VI. Half VI, half V and I. What is V? VR. V means not V, VR. 4.47 at angle 56 degrees. And I is nothing but 1.18, 56 degrees. So both are same angle. So it will cancel out. Cos of 0, 1. Cos 0 is 1. So only multiply the real parts. V and I, 1.118, 4.4772. 472. So how much? Half 4 point, this one, 2.5 watts. So how much is power supplied? 2.5. How much power absorbed in resistor? 2.5 watts. So what is the power in the capacitor? No power. No power in the capacitor. Pure capacitance, pure inductance won't absorb any power. So which is the same, the average power supplied. Zero average power is absorbed by the capacitor. So like this, we have this one. Okay, this is a summary. You can read it. Not that much important. Okay, so I have some problems. If you want, you can solve. Okay.